It's generally worked, other than one time where I completely screwed it up. But no, generally it's worked every time we've been going through it. And I am showing that we are sending data and online to everywhere. So welcome to everyone who has and can see us. I'm showing that we are online everywhere other than Twitch, and we're sending data there. So as we give everyone the opportunity to get into the room, I will make kind of the general pre-show announcements like I normally do. So if you guys are watching for the first time, please remember to hit that like button, comment with any questions that you have for Vlad, myself, or our guest on episode 8, Jim Gavigan here. And subscribe to the show on LinkedIn and YouTube, all your normal platforms. I'm supposed to tell you to hit the 5-star rating on Apple Podcasts, and maybe someone will actually do that this week. If you guys are following us, you can follow all the shows everywhere you normally see them, plus online at manufacturinghub.live. A couple of community comments. I know Vlad was in the open oil field conversation on Clubhouse last week, and that seems to be getting better and better. We've had a couple of comments on there. I missed it last week. I will miss it this week, as it is Beth's birthday, and we are going to be in a national park without cell phone service somewhere, and she'd probably murder me if I tried to stop that in order to jump on a conversation. Other than that, we're going to continue to roll with our new weekly schedule, this theme being manufacturing intelligence. And if you guys have any community comments, please feel free to send them in, and we will get them read before we officially start the show. Any other comments before we jump into it, Vlad?
I was gonna say the oil event happens on Clubhouse at noon Central Time this Friday.
Noon Mountain Time.
Mountain Time. Yes. That's right.
I only remember because it's different. No one generally uses Mountain Time as their standard measurements.
Yeah, and I don't remember the exact topic, but it should be interesting. Chanterelle is going to be presenting a few things. I believe it's going to be on container programming, so Kubernetes, that sort of thing, but should be good.
No, fantastic. Do you want to start it off, Vlad, or would you like me to kick it off?
I'll let you do it. I've got all my systems pulled up, so it looks like we are live everywhere. If you
Awesome.
Want to give us an introduction?
Yes, perfect. Hey, everyone. My name is Dave Griffith, and with my co-host here, Vladimir Romanov, we are Manufacturing Hub. We are currently running our 8th episode with our exceptionally special guest, Jim Gavigan from Industrial Insight. As you can see, Jim and I have nearly matching hats. Jim and I have nearly matching hats, and we're very excited to have Jim on here. I will probably make note that Jim is one of the most humble people that I know in this ecosystem, and so I'm probably going to say something, and he's probably going to try to walk it back once or twice during the show. But no, welcome to the show, Jim. We're extremely happy to have you.
Appreciate you guys having me.
No, fantastic. So, Jim, as I mentioned, so you currently run a now 4-person company called Industrial Insight, and you guys are manufacturing intelligence specialists. You guys are a niche service provider for that, and you have your title. Your title is one of my favorite titles ever. You are the Chief Time Series Data Storyteller. Did I get that correct?
You did. You got it perfect. Yep.
Awesome. Can you tell us how you came up with that?
Oh gosh, I don't know. It's probably one of those moments on LinkedIn where I was looking down and I don't know, I saw something creative and it sparked that in me. And I said, that's kind of what we are, is we tell stories with data, and we work with time series data, and I run the company, so I'm the chief. There you go. Chief Time Series Data Storyteller, it just kind of worked, and a lot of people get a kick out of it. It's same like it's funny when I email somebody from my cell phone, it says, please excuse the brevity and the yit pose, so I do a typo right there at the end. So it's kind of one of those things, just have to play on it and just see where it goes,
I mean, it's pretty interesting. It seems intriguing enough to, someone to want to ask you, like, what exactly do
What
you
does
do
that
with data?
mean?
Like, yeah,
Yeah.
what do you, like, can you tell us a little more about what your company does so we get
Yeah.
a better
So,
idea?
yeah. So we work, primarily with time series data systems. I mean, the biggest one out there obviously is OSI PI, which is now actually owned by Aviva.
Mhm.
That just finalized in the last, couple weeks, probably. Um, that's the bulk of our work today. But really we're time series data experts. And, that happens to be the king, in that space, today, and has been for a long time. And I used to work at OSI and knew a lot of customers that, needed help really making sense of their data. I mean, I'll never forget, my good friend Sean Reed at International Paper at Rome, Georgia. I never forget one thing he said to me one day and this was when I was at OSI Soft. He said, Jim, I got 20 years worth of data. I don't know what it's telling me, because he had a major problem in a particular area of the mill, and he's like, I got all kinds of data. I don't know how to decipher it and make sense of it and do something about it. And I think that's really what we do is we take all this time series data that people are collecting out of their control systems, and we help them make sense out of it and do it proactively instead of just, oh, something broke, let's go look in Pi and see what happened. We try to get it to where people are driving their business by that. So.
I'm curious about the approach. So when you have a customer, and I think there's a lot of people that probably identify as such, where they are collecting data, right? So they have a systems integrator that plants in a PLC system that writes to the SQL database, and it is collecting whatever they've put in. What would be your first step, and obviously subsequent steps or recommendations to these
Yeah.
people?
Well, the first thing, SQL is not a time series database. Let's just get
Right.
that straight, right? It's going to bloat. I mean, at some point it's going to bloat on you, right? Because there's no compression. There's no way to, there's no way to ensure that what you're putting in there isn't going to be junk. And realistically, that's kind of the same way. Well, there's actually ways to do it in some systems, but most people don't take those steps. But the first thing is you don't just go throw it in a SQL database and hope you're going to get any kind of performance out of it. That's a number one. A time series database is built specifically for retrieving data, at maybe not even the same interval, and SQL is great at row, column, everything's kind of on a level playing field. It's not going to handle multiple timestamps, well. So time series databases are built to handle, things that are not exactly at the same timestamp, going in, and it's not all in one row. And the time series databases, the historians, as we've always called them, have some means to compress out, either if you're getting the exact same data or if it's just instrument noise, they have a way to either ignore it or compress it out, don't store it at all. There's several different companies that handle it different, and they have different opinions on it. And that's neither here nor there. I mean, there's good ways to handle it, but SQL does not handle it.
Could you
So,
still utilize any of that information? And obviously, there's no, one size fits all answer. You'd probably have to look at it, but could you still recover some of that data and make it usable to the customer? Or you'd probably recommend starting something different?
no, you could probably make use of it. I know, like some of the things we've done in the past, like especially with Pi, they have what's called a UFL interface, Universal File Loader. So it's designed to take a flat file and bring data in. So a lot of times, I mean, I've pulled data in from a spreadsheet. I was doing a simulation application one time, and a customer gave me some data. They were generous enough to give me some data. We just pulled it out with Pi Data Link. It was just their Excel add-in. Pulled out the data, and we just did it, at a specific time. Because that was just the easiest thing for us to do. And I actually pulled it into our test database. In that UFL, it said, okay, column 1 is the tag name, column 2 is the timestamp, column 3 is the, is the actual value. So you can always configure that, to do that. So you can usually make sense of it, if you can get at the raw files, so you can always use it.
Gotcha.
So.
But going forward, I guess you'd probably recommend a different database, but also, I guess, a different approach to how they gather data, because you'd probably have to assess, obviously, how, like, which points they're gathering, what makes sense to them, and go through an entire, I guess, like, what's your experience on figuring out the right data that's being sent to your database? Like,
So almost always your first iterations, you're going to collect way too much or not nearly enough. I mean, that's just what happens to people. And you can always build or scale back, right? And a lot of it depends on kind of the price tag, like a lot of the historian systems have traditionally been priced by tag, by how many data points you're going to collect and store.
right.
Sometimes that drives some of the decision making. So then, sometimes you may err on the side of too little, but certainly you get with your subject matter experts over what is the critical machine or process data that you ought to collect. And then it's going to grow and evolve over time, because sometimes you're going to be looking at a problem. You're going to say, gosh, I really wish I had this data as well. So then you start collecting. I mean, obviously you can't, you can't go get data from the past, but you can at least get it going forward. So we typically try to get people to err on the side of collecting a little too much data, and even when we're doing and we'll talk about this a little later, but when we're doing some of our data fidelity work and data fidelity studies, we will always tell the customer to err on collecting a little too much data than not enough, because you can always clean it. You can't put more in it because you don't know what it was. So, again, you have to get with your subject matter experts, know what's critical to the machine or process, start there. You're probably going to be wrong to a certain degree, and you can always iterate. That's my opinion.
Yeah, makes sense. We got a question from Noman on LinkedIn. He's asking, I'm curious to know if Jim has been asked to import data from physical media such as CDs or paper into Pi. Are there firms out there that specialize in digitalization of such data into flat files, as Jim mentioned, and that would then be utilized by a Pi admin to bring it into Pi?
I haven't heard of something like that. The challenge is just getting it from paper to digital. I mean, that's not really my space, but I would think there's got to be a way to get that with optical character recognition. We've had that for years. I mean, I would think you could at least get it into like CSV type files if it's organized decently. But yeah, I mean, then it's just the UFL approach. If you can get it to a flat structure, it's UFL, but I don't see why you couldn't do what he was asking, for sure. The challenge is just getting it into a format that's readable.
Yeah, it's an interesting point. I guess like maybe smaller facilities still have a lot of paper collection processes in place, right? So it's definitely going to be different than your Fortune 500 companies, and so maybe that data needs to be.
What's interesting is one of our customers, and they continue to grow with us, is a small food ingredient handling company. They're private. I've been to some of their facilities. You would not think they would be running Pi, but one of their directors, who's like kind of director over like engineering and, projects and stuff like that, he came from Georgia Pacific, and they're a big Pi user. And he's like, we got to have this. We got to have the data. And so, I mean, I don't know of any of their systems that are over 500 tags, and I don't think they're even using all the tags in the 500 tag systems. But what's interesting is one of my employees has been, she's Tia Eberline. She's been working with them, just doing like some basic batch reporting and things like that they never had before. It was all on paper. And, it took, realistically, a couple of weeks to get, maybe not even that, because I'm trying to think. Their Minnesota site, I think we had a PO for like a week to install the software, get some of the data and asset framework, which, they don't have a lot of tags, and build like a basic report. And I mean, she did all that in like a week. And she was telling me about a meeting she had with one of their production supervisors or production superintendents. And he was like, don't get impressed easy or often, but you just blew my mind. This is awesome. I mean, it was just like lights went off. He was like, oh my gosh, I'd never realized that this could be automated and we could have this level of detail and this level of information. Small plays. I mean, these places are tiny, so
I believe it. I believe it.
and so, and the thing is, I mean, OSI soft is king, but that comes with a price tag. There's other systems that, we work with, that are out there that can do, they can do the job. Right. And so even if you're a small manufacturer and maybe you can't afford, a system that complex and like, that's what that may not be what you need. There are other systems out there that will deliver a lot of value. I really believe that. And that, that's why we've tried to work with some other systems that way. We kind of recognize, and I don't hope my OSI friends don't take any of this the wrong way. Cause I mean, they know how much I promote their stuff. Cause I think it's great. I work there. I would have never worked there if I didn't think it was great, but there are just some customers that can't or won't afford that. They don't see that kind of value in it. And they're like, I need something cheaper. I mean, I'd be glad to do it, but I can't pay that. And that's why we've worked with some other companies, it's why, we've looked at Canary and we've got another, I'm not going to reveal who they are yet, but had another one approach us actually from the marketing that Dave and I've been doing. One of their salespeople said, hey, I really like what you're doing. And, we think we'd like you guys to help us out. And so we've been meeting with them some. So I'm really excited about that, because not everybody uses Pi.
No, for sure. I definitely understand. Dave, did you want to jump in and ask a question as well? I've got many more, but
Yes, no. I think what you were saying, Jim, about working with small facilities kind of brings up a good question. For that specific, smaller food and bev manufacturer, it was someone that came in that said, hey, we really need to use this data. We need to harness the data and we can benefit from that. And I'm sure that they have benefited from that tremendously over paper chart recorders, as Vlad was saying. There's a huge gap in there. When you're having conversations with people, are you finding that there are more and more companies who are interested in, using their data or collecting and then using their data? Are you finding, are you finding more and more companies are realizing that they need to collect and use data?
I think so. I mean, the conversations that I'm having, like I'm having the same conversations I had 5 years ago when I started doing technical solutions. We haven't really talked about my background. I'll give that to everybody in a minute. But since I started doing technical solutions in the time series data space, which has been, I guess, 5.5 years now, my conversations, the things I'm talking about really haven't changed. They're just easier to have. Those conversations are easier to have because I think there's been more marketing, there's more education, there's more people thinking, yeah, I really need that. And it's funny, we can actually kind of thank, people like IBM, GE, and, Accenture, some of these guys that spend a buku amount of money, who, I don't know, I'm not going to say it because I know people are going to be listening, but, maybe don't deliver quite as much, or have struggled. I mean, let's look at GE Predicts, right? I mean, they were advertising all the time, right? And they had that kind of geeky guy, and, his dad was trying to give him his granddad's old hammer. You're going to work for GE. Here's a hammer. And the guy's like, oh, I'm writing code, I think those things actually really helped. Even though Predicts never lived up to what everybody wanted it to be or what they were hyping it to be. The reality is that helped the market because it got more people thinking about it. It did. And so my conversations are easier today, Dave. I mean, yeah, I think there's more people wanting to collect data. I think there's more people wanting to actually figure out how to use it.
We got a question, Jim, on YouTube that relates to that. So the question is this data mainly for predictive maintenance or is it to make the process more efficient? I would assume it's a little bit of both, but I'm curious how you'd elaborate.
Yes. I mean, realistically, you're collecting all the sensor information from all your equipment. So I got a funny story about predictive maintenance. I'll tell you in a minute. Yes, it can apply to predictive maintenance, of course, if you're collecting the data. And I'll give you a couple of examples where that's not happening, where somebody says, oh, we want to do predictive maintenance. Are you sure? Because you're not acting like it. But, it's for process optimization. It's for, tracking your raw material and energy costs. It's for understanding where your bottlenecks are. I mean, it's for everything. If you're not collecting and looking at this data, you're flying blind. You are absolutely flying blind. You're driving down the road and you have no dashboard. You don't know how fast you're going. I hope I got enough gas. That's what you're doing in manufacturing if you're not collecting and utilizing this data. So funny story on the predictive maintenance, right? So we have a customer that, and this was like under a previous plant manager. He said, yeah, we want to do condition-based maintenance, or some people at the plant did. It wasn't necessarily him. I said, okay, great. And so we looked at this one compressor, and it cost them, 6 figures to repair the thing. And it can cost them a couple of days of downtime if they don't have enough of that product that it makes, hanging around. Like it can really cost them. And I said, okay. So I did the asset framework model, and I kind of looked at all the sensors. I built a little display on Pi Vision, and I said, so there's a problem here. Is the outboard bearing on the motor has said 500 degrees Fahrenheit for the last 5 years. Exactly. Flat line, 500 degrees. I don't believe that, because you would have cooked it, obviously. But what am I supposed to do with that? And oh, by the way, I'm kind of like looking at this data, and I'm looking at the inboard bearing temperature, which does change. I said, I can tell that this thing sits outside. It's not in air conditioned room or, climate controlled room. I said, because I was looking at the temperature, and it was like, like 40 some odd degrees. And so I went and looked at the weather app, and I'm like, yeah, it's about 45 degrees outside. It's about 45 degrees at that bearing. Okay. This thing sits outside. I said, so you don't have the actual weather data coming in. What you really want to know is how much does that bearing, what's the delta T across it? Because if that bearing's reading 120 degrees and it's 45 degrees ambient, that's a different answer than it's 120 degrees and it's 90 degrees ambient. So, and then I had another one there, they're like, oh, we want to do condition-based maintenance on our pumps. The only thing I know about their pumps is that they're running. I don't know inlet and outlet pressure, suction and discharge pressure. I don't know horsepower. Like, okay, well, I really can't tell you much about the pump except it's running and how much it ran, how many times you tried to start it. And actually they had one, interestingly enough, I did do a calculation because I noticed that they were jogging one a bunch. And it turned out they had solids in this line. So they would sit there and jog this pump over and over and over again so they wouldn't plug the line. I'm like, I wonder why you've had so many seal failures on this. Like, look how many times you're trying to start it. Look how many times you're trying to, start it and stop it, in a very short interval of time. No wonder you're blowing seals out of it. Like, yeah, we know we're actually, trying to get it, get that fixed. But, just from running, I was able to kind of figure that out, and it was just a kind of very interesting use case. But you can do condition-based maintenance. But what I find most often is people haven't put the sensors in. 1, 2, they're not maintaining them. So yeah, you can have that temperature sensor on that bearing, but nobody's ever tried to fix that. And even since I pointed it out a couple of times, it's still not fixed. I've seen vibration sensors on it. I saw the machine was off and I was still getting vibration. But I was kind of looking at old data, because like it was flatlined at 0. I'm like, okay, these don't work at all. They're disconnected. So then when I was going back, there were literally times the machine was off, but yet there was still, it looked like it was vibrating. So I'm like, okay, I don't trust any of that. So yes, it can be done, but you have to censor it and you have to maintain the sensors.
Yeah, no, I mean, that definitely makes sense. I want to expand a little bit on that and on the previous point that that you had made. So the example that you gave, there was a champion, so to speak, that understood, I feel, the value of data, and probably, you know, like convinced maybe the management team at that plant that it's something that they needed implemented. But if you go in maybe to a customer that's, let's say, always mentions like, we've done it this way, so we're going to keep recording it on paper, we're
Yeah.
going to do it the way we've always done it, and
That's dangerous words in
perhaps,
manufacturing.
of course, I certainly believe it, but I guess I want to understand, how do you convey the value to them before maybe you have specific use cases, right? And of course, you can probably walk out to the manufacturing floor and ask questions, but how do you kind of structure that before you have those like very narrow use cases like in, and you can show them like the dollar value that they could save?
So that's an interesting one. So it's actually a difficult conversation when people are really comfortable in this is the way we've always done it.
Mm-hmm.
So I start to ask some really pointed questions. It's kind of like this is, you know, someone who's very obese and they say, I really want to lose weight. And so you're like, okay, well, you know, here's a diet plan, you know, and not a diet, but here's a plan for good nutrition. Here's how you need to exercise. And, you know, for the next week, they eat double cheeseburgers for lunch, large Cokes, you know, and then you know, huge burrito for dinner, you know, with 3 glasses of sweet tea. Wash that down with key lime pie. And then they wonder, like, well, why haven't I lost any weight? Do you really want to? I think that's the first thing you have to really kind of figure out is, do they want to change? Are they committed to it? Yeah, this is the way we've always done it, but we've recognized we've experienced some pain, either our competitors taking business from us, we've had some significant downtime, or there's some event that has happened where we want to change. If that has not happened, it is a difficult conversation, and I am learning more and more to walk away when I recognize people don't want to change.
That's interesting.
But what I focus on is I try to focus on their pain. Like, what downtime events have you had? You know, have you had equipment that failed prematurely and you didn't really understand why? You know, are you not able to produce? You know, you've got a design rating on all your machinery and processes. Are you able to produce at that consistently? If not, why not? Do you understand why? That's a lot of money. And what was funny is I went to, you know, this small manufacturer. I went to one of their facilities out of St. Louis, and this was last year, right before the pandemic. It was like in January. I mean, small place, right? And you know, the guy and I were talking. We were walking through the plant, and I mean, I saw opportunity. I was like, yeah, there's some opportunity here. And I said, what does it really cost you? It was a 7-figure number, even in a small facility like that. Most people won't admit it, you know, or, you know, they're the kind that'll, you know, swallow a camel and gag on a gnat, you know, but you kind of have to recognize, like, do these folks want to change? If they experience significant pain and want to change, if they don't, you might as well just not waste your breath, because it's going to be a really difficult conversation. You're going to get nowhere. If they want to change, then they'll start talking.
Yeah. That's really good advice. I think that dynamic even takes place within an organization, right? You might have a certain group of people or just one person that wants to change or realizes the value of change, but then
and it doesn't matter who it is. Like, even if you're at the plant level, if it's the plant manager, if you're, you know, at a corporate level, it's the CEO. If they're the only one that wants to change and nobody else under them wants to, you're gonna have a hard time. If it's only a couple of people out on the floor, you're gonna have a hard time, you know. And you know, we're doing a project. I think I showed you some of the stuff we were working on yesterday. We were prepping for this. That goes all the way up to their CEO. They're like, we are going to go digital. And the directors, is kind of funny because they have like a steering committee that's working with our project manager, and everybody's interested in this one. Everybody. And what's been great is the subject matter experts that they're putting us in front of. we've only been working on that for about 5 weeks now, 4 or 5 weeks. They're bringing us use cases now already.
Mm-hmm.
They're like, oh, we see what we can do now. Wow, let me show you what I'm doing because I think this could be done better. That's when it's magic. When it's 1 or 2 people or a small group. Yeah, I mean, don't like discount that because that can catch fire and do something. Like I've got a friend of mine, Jim Merritt. I mean, I think I can use his name here at Vulcan Materials. Okay. For years, he was the guy. He was director of engineering. He was the guy that believed in using data. And he kept just doing little projects as he could. And it was funny. I remember, a friend of mine introduced me to him. One of my former colleagues introduced me to him. And Jim literally tells me our first conversation, he said, Jim, he goes, I will take all the free advice you give me. Do not let me take advantage of you. I said, well, Jim, I appreciate that. But, I like to help people. Right. So if I feel like you're taking advantage, I'll shut up or I'll stop calling you or I won't answer the phone. I'll say, hey, I can't help. I need a PO for that.
Mm-hmm.
And interestingly enough, they are starting to go through, and I helped them with a little bit of consulting on it, go through putting in a data infrastructure across all their plants. But it was that one guy who believed in it and he kept working on it and showing people like, here's what we could be doing. Here's what we could be doing. Here's what we could be doing. And he was fortunately at a high enough position and who also worked with people down below that he got both sides to believe. Right. So you don't discount it. Right. I mean, it took him like he had been working on this for a couple of years when I talked to him, and then it was another 3 years. So, I mean, he'd probably been working on it for 5 years, but he believed for their company, he believed, and he kept banging away,
Right.
And so sometimes like us as the vendor, cause you're a vendor just like me, sometimes we can't be the one that keeps beating on that rock. We stay in contact, try to keep educating, which is what I try to do. But sometimes we have to kind of walk away. We're wasting our time, wasting our breath. There's somebody else out there who wants your help. So, yeah.
I'm curious about the use cases also. Sorry, I guess I'm throwing in a lot of questions.
Sorry, man.
Dave, come
Hit me.
But so obviously I'm thinking that you have like 2 different avenues once you're working with a customer, right? So you can, once you integrate your data collection system, you can start looking through it and finding use cases on your own. So something that they might not be aware of, right? It's like what they don't know, what's the unknown that they don't know about. And then you've got use cases that they bring you. What's kind of, I guess, like, how do you figure out which ones to go after, and like how do you allocate your time maybe between the 2 opportunities, because there could be big opportunities in things that they don't know, right?
For sure. So my philosophy, unfortunately, since I've been small and especially when it was just me, I didn't care. Like I invested the time, whatever it took, and I would go digging around the data just to see what I could find. And that's when I was learning like Tableau and Power BI. I remember I was working at a paper mill, took a bunch of digester cooks. I took 80,000 digester cooks across 4 years. They were doing about 20,000 a year. I threw them into Tableau. I was literally sitting in this office like at midnight on a Friday night. My youngest son comes walking. He's like, Dad, what are you doing? So, man, I'm learning this cool new software called Tableau. I just took all these events, these digester cooks, and I was evaluating them. And I'm like, oh, did you guys realize, digester 1, you used to have 22% of your cooks were A cooks. Now they're 0. What happened? And on
percentage?
Huh?
What's the percentage?
It was like 22 were A because they grade them A, B, C, D, and then held cook. So in other words, they had to hold it because of something going on. And so they overcooked the pulp. So they had 22% the first year. I looked at 4 years. It was 22% were A, graded A on digester 1. By year 4, it was 0. I said, you keep complaining about pulp quality. Think this might have something to do with it? I couldn't get anybody to look at it, actually. I mean, I found some stuff. I remember I found one, I remember even talking to one of their engineers. She was like, yeah, like every day we talk about energy costs. I said, well, I'm pretty sure, like I've looked at your average steam usage across all your cooks for the last 4 years, and you're averaging, I don't know, it's like 2,000 pounds of cook more. So it's like 4 million pounds of steam extra. And oh, by the way, I equated that to weather patterns, and no, it's getting warmer. So all the global warming folks can run off a joke if you want. But no, it was actually warmer on average over the 3 years, but literally they were using more and more steam. Couldn't get anybody to look at it. And so, I like to dig around in the data. I'm just a curious person, and I encourage my people to do that. How do we get there, and then what do we go look at? Because that was kind of the original question. I always tell people, I say, let's go after something that has $500,000 or more in value that I think we can make a dent in 4 to 6 weeks. Because here's the thing, in like 4 weeks, that's about $30,000 about, if you spend that with us, about 30 grand. I'm like, even if you spend twice as much and get half the benefit, you spent 60 grand and got $250,000 in benefit. Even if you got a quarter of it. Right. So let's go after something that we really think like we can make a dent in. And, you can talk about it. I mean, I've got enough experience now that I can kind of say, yeah, that one should be pretty easy, or God, that's going to be a nightmare. No, let's stay away from that one. Just because I've done this stuff enough, and we've played with this stuff enough. But that thing I showed you yesterday, those XY plots of the pump curves, that's millions of dollars. You know how long that took to put that together in that state?
Probably several months.
Day and a half.
But all that data was ready? Or is that like including data collection?
Well, the data was already there.
Okay.
I just had to put it in the asset framework model. I had to build 5 calculations. Actually, we'll give it 2 days. We'll give it 3, including the AF model. How's that? 3 days for everything, and to clean it up and make it neat. Literally, that the engineer gave me that use case. He called me on a Friday at lunch. I was out to lunch with my wife, and he said, "Hey, how do I do calculations in PyVision?" And I was like, "Well, what are you trying to do? I mean, it's like pretty simple." So he's telling me, and I was like, "No, here's what you have to do." And I said, let me get back and I'll send you a couple screenshots. I'll get you started. So I did that. Sends me an email back, says, "Thank you." Probably hour and a half later, 2 hours later, maybe not even that, he sends me a message on their team site and says, "Hey, here's a mock-up." So I click on the link, and it's one of those. So I go kind of look at the calculation. I'm like, hey, you got some time to like run this through with me? So we spent 2 hours on the phone on a Friday afternoon from like 4 to 6, something like that, 3 to 5, 4 to 6, something like that. I think I stayed late with him. It rained like Saturday morning. So I was like, I'm going to go work on that for a little while. I can't get out and play golf, can't go fishing, can't do a fishing Friday when it's raining. So,
right.
So, I'm like, well, I'll just work on this for a little while, So I think I spent like 2 or 3 hours, and I had a mock-up of that we could start to scale out. Then we spent an hour on it on the phone on Monday because some of the calculations were wrong. There was a density calculation that was wrong. And we troubleshot that with some of their people. We got that working. And then I've probably spent 3 or 4 hours working on making that prettier, into that state where I'm like, we can take this and actually scale it out to any pump in their fleet. So literally a few days, and that's millions of dollars. Just getting the people to look at and understand what they're looking at, that, hey, we're looking for pump wear, we're looking for a throughput issue, we got to keep it in this box, because like we had a box on the screen, like in the pump curve going through, and like keep it in that box on that curve. Like that's where you want to be, somewhere on there. I mean, and then educating their people, like, do you realize that you're not there? And now there may be extenuating circumstances that don't let them run in that box, that's okay. Well, let's document that, and that's something we're actually going to start doing, so let's let the operator kind of feed back to us like, hey, this is what I'm seeing. This is why I can't run in the box, and that could be millions of dollars a year for them, so it's things like that, And it was funny because I recognized, I'm like, that won't take very long to do. Because we knew how to do the XY plots. Ben had done it for another customer and he showed me like, hey, here's how you make all that work. So I just went back to that example. We had it on our dev system. So I went back to that example and just changed the numbers to fit their curve, and we were there. And so, those are the kind of things we look for, where this could literally be a really big thing. And we're kind of like, that's not going to take 6 months worth of data wrangling and machine learning and all that kind of stuff. We stay away from that stuff. It's literally, we look for something that we can do with first principles, like, based on relationships of, what can be done. Now, there's something I didn't show you. Dave knows this story. It's a contamination issue on an incoming stream into a plant. Now, we did some machine learning on that one, and we spent, I spent at least 2 months, maybe 2.5 months on that. But that was millions of dollars for them. It was a big issue for them. And you know what? It's not really a big issue now. What I ended up building catches the bulk of the issues they have. They see it when it comes in, and then they can deal with it much more appropriately. Could it be better? Yeah, probably. And they'll probably revise it. I know some of their research and technology engineers asked me like, hey, how'd you put this together? And so I went through a big presentation, showed them. I'm like, you guys are welcome to take anything I've done and make it better. I just knew what you had wasn't going to work. And so I tried to make it better, and so that one, I was like, okay, this could be a nightmare. Like we could spend a lot of time on this. Is this worth it? And it was. So sometimes we recognize, oh, that's a simple one and that's going to save them a lot of money. And other times it's like, this is going to be a pain in the butt and it's going to take a lot of time, but it's going to save you a lot of money. Do you want to do it?
How do you know that the data is accurate, right? And maybe taking that example that you mentioned about the pumps, and let's say you get a call saying like, hey, we've got this specific application, we got the data already coming in, and then maybe tying in some of my, again, like personal experience, some third party came in and they're, like I was kind of mentioning at the beginning, sending all this data into a SQL database, and that company calls you and asks you, well, what can we do with this? Can you give us some insights? What's your maybe initial step in figuring out whether or not it's good data?
So can you see my graph right here?
Yep.
Okay. So this is part of like the data fidelity studies we do. So this was a steam flow coming into a plant off their boilers. And what you're looking at is the green line. Let me move my mouse. The green line represents raw data. And in this interval, they've had 586 raw data points. In the Pi data archive, they had stored 2 of those. 586 raw coming in, stored 2. And I guarantee you the curve, I looked at it after I saw this. I went back and looked at the data, and it looked kind of very straight line-ish. So here's a situation where you're storing way too little data, right? And I always give the example, no, by the way, that 32 and 29, that's 1,000 pounds an hour. So if you did a totalizer on that, based on that red line, which is the 2 data points you stored one about 32.4 thousand pounds and one about 32,000 pounds. You totalize that over those couple hours or 2.5 hours, you get the wrong answer by a lot.
Right.
So when we're doing Pi, this is compression insight by pattern discovery. We work with our friend Paul Sheramato. Dave knows him quite well. So we go evaluate this. This is part of the data fidelity study service that we offer. Another one. Let me see if I can figure this one. Yeah. So this one right here was another plant that we did some work at. I did a data fidelity study at. They were storing their data at half a second, and this was a flow. And I said, I think you have actually an instrument problem here. Can you see why I said that?
Well, it seems to be bouncing between 2 extremes.
It does, but that's kind of the nature of a flow signal. But do you notice like this little there's actually kind of a line right here just below 6,000 pounds. It's kind of really should be bouncing maybe between like 5,800 and 6,000. You can kind of see it like right here,
Yeah. Yeah.
like right here. So let me zoom in. Let me show you the zoomed in trend of that. That's what it was zoomed in. And it was interesting. We had a process engineer for that area on the horn. I said, Brian, I said, I think you have an instrument issue. And when we zoomed in, he saw that and he went back and looked at some trends and he said, you know, this started about 2 months ago. He said, you're right. We do have an instrument issue because the other one doesn't do this. They had two sensors that were looking at this.
What was the sensor? Sorry, it looks almost like harmonics.
It does.
on like
It's a steam flow. It did look very harmonic to me. And so that's why and you know, the biggest lesson I told them is evidently the integrator that they had put this in thought more data is better. So let's store everything in half a second. That's not good because you're going to make really long retrieval rates, and they weren't compressing much of it out. So you're going to have really, really long retrieval times. Like, oh, you want to pull up a trend to 300 days of data for 15, 20 points to see how something correlates over time. Go to lunch and come back and hopefully it'll be done. You know, hopefully it'll be all up on the screen. And, you know, that's just something, you know, we've seen this. And so you know, one of the things we try to recommend too is, and I think I gave you this example yesterday, you know, is if you have a temperature that if you took all the heat source away or you poured the coals to it, it doesn't change more than a degree a minute. Why are you storing it every 1 second?
Because that's the limitation of the software would be my answer.
Because some data scientist said, no, give me all the raw data at 1 second,
Mm-hmm.
you know, because I have to have it. No, you're going to go clean it anyway. Let me give you actually real data here. And so what happens is you know, I've seen half a second and I've seen 1 minute data where, you know, realistically 5 to 10 seconds would have been just fine on either of those sets of signals.
We got a question before we stray too far. Someone's asking, so what do the spikes correspond with? Does that represent legitimate data? So on this graph specifically,
potentially, because flows tend to be very, very noisy because you have all of the, you just have all that mixing and stuff going on in the pipe. It's going to be up and down. It's an inherently noisy signal. But I was really, but we had looked at another signal that it didn't stray between 4,500 and almost 8,000. It was between like 5,500 and 6,500.
Right.
And I was like, this looks different to me. And if I look, I'm like looking, there's like kind of a red bar, like kind of between like 5,800 or 5,700 and 6,000, kind of running right through the middle, that I think is probably your real signal. Which then I was like, yeah, I think that's, you know, this stuff, like this is kind of normal, like attenuation that I would see. This out here looks a little bit too much.
Mm-hmm.
You know, like in here looks about right. You know, when it really spikes a lot, that starts to look a little suspect to me. And, you know, again, you know, here's one of those things, like you're taking this sample at half a second. You know, how much can that flow really change in half a second? It's a very turbulent signal anyway. You know, and so you have to really talk to the process engineer and the instrumentation people to say, okay, what can I realistically expect?
Right.
You know, maybe I do need to collect it every second or 2 seconds because it really is going to move that much. And we really do want a really accurate total. You know, maybe I have a Coriolis meter and it's really, really accurate. That's fine, you know, but just go in educated. And so many people don't. They just throw in an interval, they throw in some compression exception parameters, and they hope it's going to work. And typically what we see, like in the Pi world, we see people on the administration side. Back in the day, the administrator had gone to training, they were involved in the initial setup, they probably had some knowledge of the plant itself. The person you have now is 4 or 5 people since that person that put it in. They have 3 jobs to do, and this is one of the least important they do. Oh, somebody needs a new tag. Oh, here's one that looks kind of the same. Can copy, paste, change the name. Here you go. Does it look squiggly enough to you? Okay, good. We're good. That's how it works. There's no thought given to, are we actually going to get legitimate data? And that's why we're having to go back and do, these data fidelity studies. And, kudos to Dave. He made me go do it. He was like, Jim, he goes, there's some real value in doing this. Like, why don't you build a service around this, build an offering around it? People need this. And so, thank you to Dave for that. But
yeah, I mean, it's sorry to interrupt. It's a lot more complicated, I think, than some people may believe. Right? Like if you get closer to that instrumentation, there's a lot involved in getting the instrument right, getting the connection right, the signals right, and even
it's not complicated. It's just doing the job. And the problem, and just what I was telling you yesterday, everybody's got to run around with a fire hose in their hand.
Yeah.
Nobody has time to actually go do something right. It's not complicated at all. It's not, you kind of know, if you have a good instrument engineer, instrument tech, they know what an instrument can deliver. You have a good process engineer, they know what that instrument can deliver.
Yeah.
Right? They just have to be able to communicate that and understand, like, this is how this system works. So you have to communicate certain information to me so that I get you real data. Yeah. It's not complicated at all, but it's knowing that you have to communicate that information to actually get real data is kind of where the gap is. But it's not at all complicated. That's one of the things we wanted to talk about tonight. It's not really a mystery. It's really pretty straightforward. When you understand it, you're like, gosh, man, why did I ignore this for so many years? Why did I not understand it?
I mean, I just draw from my past experience at the peanut butter facility that I had mentioned to Dave last week. I remember they had Coriolis meters for all kinds of ingredients, right? And so they would try to, let's say, use it as you would normally use like a water meter, right? But the problem with peanut butter is it's a non-Newtonian fluid. So depending on the temperature of the peanut butter, it's going to react differently. Exactly. And not only that, then you have problems. So they had pump problems that would introduce air into the system and all kinds of other noise. And you had like no feedback on, the state of the system. And so you would get a lot of like noisy data depending on like which period you were in. And so you'd have to correlate that back and understand like the system a lot better. Mm-hmm. There's these like strange edge cases, I feel, where I guess the instrumentation folks couldn't really fully answer like how it's going to react or even adjust that based on the different temperatures and the the process variations. So
well the nice thing is if you have a data historian, you can correlate temperature to flow. Mm-hmm. And say, okay, well, if the temperature's below this, my signals are a mess. If it's above this, where I have a decent viscosity, it flows good, then I have good data,
I agree.
You can make the process changes you need. But if you don't have the data, you don't know.
For sure. And, they had some temperature sensors. Some of them were plugged in, some were not. Some were used to control a PID loop. And it's, it's one of those things where you do have to maybe bring in a process person that would kind of clarify all these variations. But no, I get it.
Yeah. Okay. Good deal. So,
and I think we should point out, as Jim's going through and talking about these, is the fact that he is very much a process expert, right?
So, I was a controls engineer for a number of years. I mean, I cut my teeth on Modicon PLCs and Magnatech VFDs and Siemens DC drives, and I did control brick plants and Eggo waffles and Klondike ice cream bars and aluminum bars and all kinds of stuff. I mean, I had to learn, and then I got into the world of Rockwell, and, I know their stuff really well, so that's kind of my background, so it makes a lot more sense to me, and all this stuff. And I've been a data and statistics guy all my life. I never really realized it until I really started thinking about it. I've always been a numbers person, I've always tracked numbers and stuff, but
that's right. We never did an introduction.
No,
So,
it's okay. It's
welcome.
okay. Okay. I mean, we just kind of got into it, but for everybody, that is my background, so a lot of your audience is probably more, people like that, that's my background, still near and dear to my heart, even though, that t-shirt that I wore is kind of like old, faded, and I've outgrown it now, but I still look upon it fondly. I mean, I still remember the wars I was in plants and trying to figure out how to make crap work. I mean, that's a huge basis for what I do now. I mean, it's huge for what I do now. So one thing I wanted to kind of switch gears on you guys. So it's funny, we get a lot of, we kind of talked about this yesterday. We talk about AI, machine learning. Somebody mentioned it earlier. And I'm going to go on the record for everybody, is there's a lot of companies and data scientists out there that will kind of act like it's FM freaking magic. It's mathematics. It's FM is freaking mathematics is all it is. Okay. It's not magic. We just finally, and most of that mathematics has been around for at least 40 years. We just now have the data and compute power to actually leverage them. We're still trying to figure out what to do with them. Time series data is a little interesting to work on. And, I have experienced, and a guy I talked with a couple of weeks ago has experienced this. The data scientist comes in, doesn't really understand the process, sometimes doesn't even want to know the process, and thinks they can tell you everything that's wrong with the process. Oh, just give me all your data. I'm going to throw it in the cloud, and magically we're going to tell you everything that you've ever done wrong in your manufacturer, why your OEE is low, all that kind of stuff. And we're going to write recommendations down the PLC.
Of course.
It's just not that freaking easy. Okay. And we work on this stuff. We've done machine learning and multivariate analysis. We know, like I know for a fact, and I've talked to a lot of people who work with people like that. I mean, I've talked to people on the ground actually doing this stuff. And one of the things is I love to show this slide, and Alice Sudek from OSI software, I stole this from. But, and there's actually a website for this. There's actually, it's like funny correlations or, something like that. You can go Google it. But, literally like the first one is suicides by hanging, strangulation, and suffocation versus the number of lawyers in North Carolina. It is nearly a 1-to-1 correlation. 0.99 is an incredibly high correlation. Okay. Like 0.8 is very strong. This is 0.99. Okay. The next one, marriage rate in Mississippi versus per capita consumption of whole milk. Yeah, those two go together, right? And then I love this one, money spent on pets versus lawyers in California. So the reason why I point all this out is these tools can be very, very good at pointing out correlations that we cannot see as a human. We can't really see the pattern, or it's multiple things that are all lining up to correlate to some particular thing in the plant. You cannot ignore the subject matter expertise in your plant and in your organization to make sense of this. Because whenever I do one of these, I remember I was doing a study on apparent density at a paper mill. I was doing it pro bono because I was learning the Simca tools and everything. And I said, they said they were having this problem. I said, well, let me look at it. I mean, I said, if I find something, we'll work out a deal. You can pay me. If I don't find anything, you don't owe me anything. And I told them the very first meeting, I said, no, look, I've done some initial analysis. Now, I showed them this slide and I said, correlation is not always causation, right? I said, you're going to have to tell me what on my stuff is BS and I'll take it out of the model. Mm-hmm. Tell me what I've missed. Tell me what I need to put in there that I didn't. And immediately they're like, okay, they're more relaxed. They're like, okay, I'm more in tune. This guy's not going to just try to tell me something that, is stupid, and we found things like, hey, that has nothing to do with our process. And I think more times than not so far, machine learning, multivariate analysis has been somewhat muddy in the results that it delivers. There, especially in pharmaceutical, there are some definitive use cases where it's very, very clear. And I'm not saying there's no use cases out there, but I'm saying a lot of the ones we've worked on, a lot of the tougher things that we've tried to solve, It's a very muddy problem. But these tools are great at kind of eliminating ground. But as we talked about earlier, you have to have good data to get there. And you have to collect it at the right interval. So it's this marriage between subject matter expertise and the data scientists, and people in kind of in the real world. So anyway, I just wanted to, I want to make sure we actually talked about it, because I thought that was a pretty interesting thing we talked about yesterday. And somebody mentioned, machine learning and AI earlier tonight. And I wanted to make sure that I kind of set the record straight from my perspective.
No, I appreciate it, Jim. And we generally attempt to be respectful of people's time, despite the fact that I think every single show we do slightly goes longer and longer. But as I don't think we've done a good job talking about it, I guess, who should reach out to you at Industrial Insight? Who are the sort of clients that you're looking for? If they're watching, they should reach out.
So I'm not exactly sure how to answer that, but anyone who wants to make a difference in their organization by using their time series data more effectively. You can be an operator on the floor, who, maybe you have a little clout in your organization, or you could be a CEO, and anywhere in between. But you have to want to make a difference. I would be glad to talk to you. I'm not looking at certain industries. We try to diversify our portfolio. I mean, we've most of our customer base has been in paper and chemical, but now we're in food and bev, transportation, oil and gas. We've talked to a number of power companies. I mean, we're trying to make sure our portfolio is very, very diverse. And frankly, we love the whole manufacturing space. Mining is another one that we're kind of getting into. We love all of this, and, we want to help people. It's just that simple. So if you think we can help you, you think you've got use cases and you don't know how to get there, pick up the phone.
Jim, I've got a technical, sorry. Technical question.
Okay.
That's related to that. Because we've got a lot of engineers, technicians listening as well. And I think they are maybe sold on the concept of data. But what if they want to maybe get a hands-on experience or learn more about OSI PI, like how that really like ties in or would tie in into their system? Is there a way to maybe try it at home? Like, where would one go to kind of learn a bit more about the like data gathering, let's say, process at first?
So OSI Soft does not do, there's not a great trial program. I'm not saying that they won't, but it's not like they're going to let you go to their website and download it. I think a couple of other companies are toying with it, to allow you to do that. And even may have like kind of a virtual environment. A couple of them do actually have some virtual environments.
Okay.
And you could probably like email me offline, like if you remember who it is, like, I'll see if I can find those and see if that's real. I've been told that. I've never gone and actually explored it. Probably one of the best ways to look, like if you want to look specifically at OSI Soft, they have a great YouTube channel.
Okay.
It explains, how their stuff works, what all you can do with it. It's great. We've learned a lot from it, actually. I mean, if there's something that we haven't covered in a long time, we go find one of their YouTube videos, like, okay, well, I got to remember how this part of the system works, and it'll walk you right through every step, but they've done a really good job with that, of educating.
Awesome. Appreciate it.
Yep.
I think we'd be negligent if we didn't mention all of Jim's OSI Soft Pi videos. He has a whole series of them. Yeah, just a couple. No, he has a whole series of them on asset framework and kind of most everything else Pi. Well above, I think, anyone else's head in this conversation. Does Jimmy go through and kind of explain how all of that works?
Yeah, and really what I try to hit is the things that OSI Soft is not going to hit. Like, I'm not going to repeat their stuff, right? They have videos that tell you how basically some of their stuff works. I'm trying to teach you, how to think about some things and how to use some things very, very specifically. You know, and I've also got stuff on Power BI out there, some stuff on Simca, which is a multivariate tool. Dave, I think, you know, we're still releasing some of those videos out, you know, which we think is a great, you know, multivariate tool. So kind of we try to walk you through that. I mean, if you go to the Industrial Insight YouTube channel, like I've really tried to do a good job educating people on what's possible and how they need to be thinking about things. Very rarely, except when Dave like yanks my arm and twists it behind my back, which he did recently. And we haven't released it yet, but we shot a video series on some of the services we offer. And, you know, that's the only time I would even like sell to you. I don't really believe in that. The main reason why I started doing the YouTube channels was to educate the market and to try to really gain credibility out there, right? And show people like, hey, we're really credible. We actually know what we're doing. Mm-hmm. And so I try to shoot things that really show like, here are the things that you could be thinking about. Here are the things you need to be doing, you know, and, you know, try to be, you know, I've got to blur out customer data, obviously, you know, but I try to be as specific as I can without giving away like who it is and what the process really is. So,
yeah, makes sense. I've posted the link, by the way, in our social media channels, and it will also be posted, I guess, on the recording underneath. So you can always,
yeah, and that, you know, and I've got a pretty extensive blog library on our website. You know, I've written a bunch of things, you know, before I started doing the YouTube stuff. I did a lot of writing. I haven't done a lot of writing recently. I probably need to start back. I haven't been as motivated to do that, but there's a lot of things that I, you know, we still, you know, if you connect with me on LinkedIn, you know, Dave still goes through there and he finds something that, you know, we haven't posted in a while, you know, for all those people that, you know, haven't been around, you know, we find an old one and, you know, throw it up there and say, hey, you know, in case you missed this a couple of years ago, you know, we talked about this. And, you know, I just try to make you think, you know, and a lot of times, you know, that was just a creative outlet for me. You know, I like to write, you know, I like to do, you know, creative things from time to time. And so I kind of go through fits and spurts. So I'm not real consistent, except when Dave, you know, he's been working with me and, you know, he's kind of my marketing guy. He's my marketing department. So he makes me be more consistent, you know. But I mean, that's something I've struggled with, but, you know, the whole idea and intent of all of that was to make people think and to educate people, you know, get them thinking, you know, correctly. And hopefully that, you know, you kind of hope down the road, somebody says, hey, this guy seems pretty good. You know, it seems like they know what they're doing. You know, maybe I ought to give them a call and see if they can help us. You know, I mean, we never mind that, but, you know, really it was about, you know, trying to help people first, you know, and hopefully people might actually pick up the phone one day. So, but those are a couple of places you can find us. I mean, that's probably where, you know, we're really active on LinkedIn, you know, YouTube and then our website. You know, I have been a little remiss at putting some of the content we've been shooting up there, but you can go find that, you know, and there's plenty of educational stuff up there.
Awesome. Appreciate it. Dave, do you want to wrap us up? I think we're...
Yes. No. Thank you, Vlad. Thank you, Jim, once again, and everyone that has listened. Again, thank you guys for listening. Thank you, Jim, for coming on. If you are looking for Jim, again, Vlad mentioned, you can go find him on the links, but also industrialinsightinc.com. And if you search on YouTube, the Industrial Insight YouTube channel, as well as connect with Jim on LinkedIn. I know that that's where he and I met. That's where I think he and Vlad also met. He is around there all the time, and honestly, one of the most knowledgeable people in the data space. He's probably too humble to agree with me when I say that, but certainly in my network, he is one of the most knowledgeable people in the data space. And so again, Jim, we thank you very much for taking the time out.
You know, here's the thing on that, Dave, is I've worked very hard trying to understand the space. I work very hard at, and all my people do. We work hard at trying to figure this stuff out and try to figure out how to lead people. I mean, I feel like there's a gap in the market here. And, you know, I've been blessed with a gift, you know, and that is, you know, looking at data and making sense of it. That's a gift that I've been given. I'm trying to make the most of that. And, you know, you can call that humility, you know, whatever it is, but, you know, I'm just trying to make the most of a gift and work really hard at it and share my opinions, you know, and even if Even if you disagree, I mean, that's fine. I invite people to disagree with me. That's fine. Usually I'm right. No, I'm just kidding. Actually, I've had a couple people like, I really thought you were wrong, but you're actually right. You made me think differently. But I've had some people do that to me too. I mean, I was like, crap, I'm really off base here. And I think that's really what the community and what all that's about is, if you're putting that work in, share your knowledge. And you're gonna help people who are looking for that expertise, but also you're going to invite people who are going to help you grow and challenge everything you're thinking about. So, I mean, you should share. I mean, that's kind of what we're looking to do. And so, I mean, it's just my opinion. It's my own school of hard knocks and my experiences. And I don't claim to know necessarily any more than anybody else. It's just this is my experience, and here's what I think. So,
Thanks, Jim. Really appreciate it.
Thank you guys. I appreciate y'all. I appreciate y'all doing this. I mean, it's always fun to come do these kind of things. I really enjoy doing it. So I never mind talking. You know that, Dave. We never have a short conversation.
No.
I mean,
we never do.
We had so many other questions and topics planned that I feel that we'll probably have to do a second episode at some point. But yeah, it's it's a very interesting conversation, and I think the space is only going to continue to grow. Right? There's a lot of innovation happening in the space. And there's different ways. I mean, like we can go on a whole tangent about like the technologies used to gather data, store data, process data, collect data. Like there's so many different solutions that that's just like one avenue, but there's a whole aspect, I think, on the human side as well, right? Like some of the things that you've mentioned, but also, we talked about turnover of your employees, how people are staying less or longer. So there's many topics I think we can dive into at a later time.
Yeah, and I'll leave it. This will be kind of my last statement, but you're talking about the technologies and all that. Here's the thing I tell a lot of people, and I told this recently to a customer. We didn't win the project actually, but in the first 5 minutes, I told them, I said, I know the other two companies you're looking at, and they were looking to either do something with Pi or they were looking to use two different like systems. So we were kind of the only like independent integrator that was looking to use like what they already owned. But I told them in the first 5 minutes, I said, any of those systems will work. They will. They'll do the job that you're asking them to do. Some better than others, I mean, but, I think what we're offering and, one other one would probably be a much better choice than the third one. But they will all do the work. It's really about the people, and it's about change management. It's about, are you going to embrace it and actually do something with it? The technology works. Like there's a bunch of technology that works. Are you actually going to go use it? There's a bunch of ways to like lose weight, gain muscle. But if you don't actually go do the work, you don't actually eat right, and you don't actually go do the exercise, you're not going to get there. This is the same in our world. So I'll leave it at that.
No, perfect, Jim. Thank you very much. And so until next week, we'll see you guys soon. Bye-bye.
Thanks.